When I studied medicine, the textbooks were of some size, and we could see that they had grown from decade to decade, and that's 20 years ago. And since then, I hope they've gotten better at making them shorter, but it's not because their knowledge has not exploded, right? The problem is not having the knowledge as a society, as a specialty. The problem is being able to apply that knowledge to that patient case.
Today, we're mostly going to be talking about multi-agent frameworks, specifically their application within healthcare. Let's first just talk a little bit about why it is that we even want AI in the healthcare space. So ultimately, what problem we're trying to solve. And Lars, because you're furthest away, I'm going to start with you.
I think so. As far as I see it, AI holds a lot of promise within healthcare because of the complexity of healthcare. AI is still not living up to that promise. So I think that, in my view, if we need to all make sure that AI can actually live up to that promise in healthcare and be able to assist the clinicians that are hard at work in healthcare on overtaking some of their administrative burden, first and foremost, and also starting to support them by being an intelligent partner towards the patient dialogues and patient interactions as a whole.
From a research point of view, what do you think it is that's kind of lacking in that space, though, just when you're reading what's being published?
Yeah, so when I'm looking at research from the last 10 years, especially, a lot of people believe that this one LLM as a monolithic system here can do the whole thing by itself and be super intelligent. But the problem is that one LLM doesn't have access to clinical information that we can rely on. And furthermore, the problem is that it has tendency of hallucinating. So imagine having that LLM as a partner, being a seasoned clinician like Lasse, sitting there with this LLM that sometimes provide a really intelligent answer, but also sometimes can hallucinate like wild, and you never know when it's intelligent and when it's hallucinating. That's a big problem. So thereby, I'm a firm believer that AI needs to go into what we in machine learning would call a priori knowledge, which is basically just a fancy word of saying knowledge that is actually defined by clinicians, expert clinicians that are in councils and stuff like that, to make sure that the knowledge that the AI is drawing on is useful knowledge.
From a product point of view, how do you make sure that this is something that like the general population here can actually access?
So I think outside of the tech world that we inhabit, there's a little bit of disillusionment about how AI actually affects one's workday. And really it comes down to how it's integrated. So if you're a computer programmer, you're writing software, for example, the tools that we have for integrating AI into coding workflows are really strong. Whereas outside of that world, and particularly in healthcare, we have these sort of standalone solutions that are separated from your EHR systems, your electronic health record systems. They're separate from anything that has knowledge of patient records. They're separate from your knowledge bases and reference databases that you might refer to. And so it's not integrated into existing workflows. I think that's one of the big opportunities for AI. That's how AI is going to become more incorporated into an individual clinician's like workday.
So then, Lasse, not to be rude to my colleagues here, but if you have engineers and product developers talking about everything that's necessary in this healthcare space, now that we've actually been trying to build and apply AI, not just Cordy, but all sorts of companies for the healthcare space for quite a while now, from a clinician's point of view, what is it that we absolutely have to get right? And what is it that is the difference between building something that looks great on a computer back in the office versus actually having a positive impact?
Yeah, well, it depends on understanding what the problem is in healthcare, and there's this burnout epidemic, and the question is what fuels that. And with ambient scribes, we're trying to take out a part of that, right? Taking some of this administrative load, but the problem is bigger than that. And the main problem, as I see it, is that modern medicine has simply become too big for any human brain to comprehend. Perhaps if you myopically focus on your highly specialized niche, you might be in a position where you can forget about the rest and then actually know that and be able to practice that completely perfectly. But that is a rare case. And in general, what you're trying to do is you're trying to provide the right care based on this huge amount of options, and that is becoming increasingly difficult. When I studied medicine, the textbooks were of some size, and we could see that they had grown from decade to decade, and that's 20 years ago. And since then, I hope they've gotten better at making them shorter, but it's not because their knowledge has not exploded, right? The problem is not having the knowledge as a society, as a specialty. The problem is being able to apply that knowledge to that patient case. And that is not just about taking away administrative tasks. It is definitely part of it. Automating tasks, fully automating some tasks like ordering imaging and making prescriptions so that you just have to verify it, fully automating those. But it's also about helping bringing that complex knowledge in terms of differential diagnosis and treatment options and therapeutic options, bringing that to be present right when you need it. Not later in the evening when you have time to read up on this weird thing that you're looking at, but right now, to get the information right now, and not from the internet. Like, the patient doesn't want you to Google things. I don't want you to Google things, but I want you to look up in some trusted resource, like UpToDate or Amboss or stuff like that. But you need it easy and fast and immediately, and that's where an agentic, multi-agentic framework can help you, where it knows the context and can bringing this information from this resource in an intelligent way that's fitted to the conversation you just had and the context of the patient you just had.
Well, I want to make that relationship because what you just said sounded a lot to me like what Lars initially said. So you have this, as you said, like healthcare space itself is growing so much and it ends up hyper specialized, and we have this healthcare fragmentation that has been this big and stubborn problem for quite a while. And as you said, it's fine so long as you're able to just focus on your particular speciality. And I think, like, to your point at the start here, Lars, that's ultimately what's changing in 2026 from previous years, is no longer expecting one language model or system to be able to do everything, but actually breaking that down into smaller tasks.
Yeah, so a multi-agent system is basically just a system that is made out of different components that can have different responsibilities. So similar to a clinician has a lot of responsibilities in his or her everyday. They need to be able to look up in guideline material. They need to look into the history of the patient. An inpatient history can easily be hundreds of pages long, and they need to have a good eye for finding out those subtle details in that and correlate that to these clinical guideline systems. A multi-agent system is able to, with its different modules, able to encompass the same tasks. And the nice thing about modularizing it is that it's also traceable to a certain extent here, right? So you have an AI that is now traceable, is looking into real data. It's not just an LLM that has learned this data and is outdated at a certain checkpoint. It's a system that can keep on being up to date on all of these data sources in real time and next to a clinician or taking over an automation task as well. Then on top of that, a multi-agent system can also do something that I feel is incredibly magical. It can also easily be deployed into the actual workflow. And what that means is that it can interact, so it can action something. So in my opinion, an agent is not an agent unless it can bring something to action. And thereby it can post some information to the electronic health record system, or it can schedule something in the scheduling planner and so on. And then suddenly back to the promise of AI in healthcare, it's basically automating a workflow that was beforehand tasked on manual labor.
So if it both has access to specific, reliable, trusted information, but it has the ability to do something with that, now you're actually getting some benefit from automation, whereas one or the other is insufficient.
Yeah, thereby you're saving real time, and also you're able to get real clinical insight, right?
How different is that from, we always pick on kind of ambient scribes because they're so established in the industry, but just how different is it from, let's say, 2025 or 2024's AI in healthcare?
Yeah, so I think that the as far as I see, like the ambient scribe introduction to healthcare is a fantastic introduction. It's like, in my opinion, it's the generation one AI brought into healthcare. And that is the fact that that has been adopted as a feature inside healthcare is strong, because now the clinicians are getting more and more used to how an AI is functioning, what the strong capabilities of the AI is, and also what the limitations of an AI is. I feel that the opportunity to take action in something it needs to be the second generation, and as far as I see, it's the second generation needs to take subtle actions such as planning something or posting some documentation to the right system, and adding the right ICD-10 codes or adding the right billing codes, all of those types of tasks that are like one step derived from the clinician's choices, etc., or medications, stuff like that. And then I think that there's a third generation that I'm very very interested in looking into in terms of actually systems that are taking more actions throughout the paths here. But let's get to second generation first.
Does this sort of product exist that Lars is describing? So something that has reliable access to information and the ability to act. Is that a mature market where there are lots of players here and it's like quite common in healthcare, or are we really at the absolute genesis of it?
So the concept of an agent, basically it's a large language model connected to a range of capabilities. It's a framework that has existed for about 2 years now. And it is, in some ways, it's become a lot more mature. Within healthcare, there are very few solutions that solve this, and typically it leaves customers with sort of two potential opportunities. Either taking something that is entirely off the shelf, that is very difficult to configure. It might work really well for certain very specific use cases, but as soon as you move into different markets, different regions that have different guidelines or different regulations, suddenly they become difficult to configure, difficult to adjust for each individual clinical requirement. On the other end of the spectrum, there have been a lot of software companies building in the health tech space that have tried to build these complex tools. They've often announced them, but they haven't actually necessarily come all the way through to being in the market because it is an incredibly complex space. The biggest challenge isn't just having a really good large language model, but it's ensuring that they're connected to the right systems. They're using those systems in a traceable way and in a trustworthy way, and that they have governance systems built in so they actually make sense for healthcare and they meet the needs from a regulatory and a safety standpoint. And so that's something that we've been spending a lot of time on, is ensuring that we can build a framework that is easy to build, powerful automation flows, like I said about these different, from taking action in the world to pulling information from trusted resources, but doing so in a way that as a clinician, you can actually validate and verify, so that we aren't relying on AI to sort of magically do a whole lot of things in the background, but to do things in an audible way. And actually, just zooming out one step, we're talking a little bit about large language models and agents. I just wanted to take a moment to explain a little bit what that is. So an agent is effectively taking the idea that we shouldn't trust a large language model for factual information. Instead, we should just say it's very, very good at reasoning how to carry out a task, but the actual tasks themselves should be carried out by specialists. So let's say you get a natural language input, maybe from a clinician asking a question or a natural language query. The large language model is exposed to a range of capabilities, and they could be different sorts of capabilities based on the needs of that end user or the regional requirements. It could be access to, Lessa mentioned about Amboss as a trusted resource. It could be regional guidelines. It could be a database of medications. It could be connections to the EHR or scheduling systems. It has access to those. It takes in that task from the user, and it plans out how to solve the task from the end user using those capabilities. But the actual actions that are happening, the information being pulled from third parties, is not based on some internal knowledge of the large language model. So when you see on ChatGPT or similar, and they said, "Oh, my knowledge cutoff was November 2023," that's something that agents don't have that problem, because they can actually pull from external resources to get information from today. And again, I don't just mean web search lookups, looking on Wikipedia or similar, but actually pulling information from patient records, for example. So the frameworks that exist can do that today. And you can actually build prototypes that give the impression of that fairly quickly. The challenge is doing so in a way that makes sense for healthcare. Because as soon as you give a large language model access to patient records, for example, we explode the opportunity for risk.
It's happening at the moment, right?
Well, exactly. And so, in fact, in truth, a lot of these tools aren't really production ready because of this gap. So as soon as you ask a large language model, fetch me this patient's allergies from their patient record. If the large language model hallucinates the patient's ID, just, moves, changes one number to another, it's completely blindly pulled the wrong patient's allergies, and now the clinician's making the wrong decisions. One of the other things that Les and I have been talking a lot about is a medical calculator that gives the agent capabilities to carry out calculations relevant for healthcare. And one of the examples that we've been looking at is insulin correction factor. So based on various factors, how much insulin, how many units of insulin should you give the patient to restore their blood glucose levels? And it's quite a simple calculation to do for a computer. There's a verified way to carry out that algorithm effectively, and we can validate that algorithm is correct. But the large language model then might regenerate that text back to the user and say something that is different from what the calculated number was. And doing that is a huge risk to a patient. You can imagine all sorts of different similar situations. Imagine just missing the decimal point, and now you've 10x the amount of insulin. Now, hopefully a clinician might catch those sorts of obviously wrong mistakes, but if it's just slightly wrong, it can have huge ramifications for the patient. So we're building a system that builds safeguards around that and ensures that these sorts of technologies can be built, can be deployed into healthcare in a trusted way, and that's really, really critical.
And I think from an AI research perspective, I think that the power of a large language model is that it's a really good natural language parser, but we cannot rely on any of the information that it's bringing forward. I know that this is a tough statement, but especially in an expert domain like healthcare, you don't want a large language model to provide you information. You can test this on your own and so on in terms of your next cooking recipe, but that cooking recipe is probably going to be somewhat right. But in terms of treating a patient, you don't want somewhat right. You want perfectly right in terms of perfectly validated information. Sometimes I see a large language model as the drunk uncle at a family party that spurts out different opinions about politics, etc. And when you're starting to actually grill that uncle a little bit in terms of their opinion, then you understand that uncle has not read the news for many years, right? So a large language model in itself cannot be relied on.
Lasser, I want to kind of hear your version of a kind of nightmare scenario. What would scare you about that?
Well, the simple question about allergies, for example, it sounds like a simple thing, right? Get allergies from the EHR. But sometimes an EHR contains a lot of information about allergies. Maybe the patient has had a suspicion of an allergy that was later found out it was not an actual allergy. They had some testing. Maybe somebody wrote something wrong in the EHR. Maybe there are conflicting information in the EHR. If we had built a system that does not think hard about contradictions and unrealistic things and stuff like that, and just blindly takes whatever seems to be the most right answer and presents that, then we have a risky situation. That's sort of what LLMs can sometimes do if they have a lot of options, and then chooses one, right? That can happen. And that would be sort of like a horror situation, to get something very convincing from patient's history and get it wrong, convincingly wrong. That would be the worst thing, because you don't need a lot of experiences with that. Something convincingly wrong, before it's not useful, then you'd have to check it all. So that would be one of them, absolutely.
What are you excited about?
Well, I'm excited about the opportunity to reduce inefficiencies in clinical work, and one of the major sources of inefficiency is the errors we make as clinicians. And I'm not only talking about these huge, terrible errors with grave consequences for the patient, right? We all fear those. I'm also talking about small errors, like you are talking to the patient in an outpatient clinic, and it's fairly complex, and you have to do a lot of things, schedule maybe a few scans, several blood tests, and make some referrals, and you forget, you also need a colonoscopy. You mention it to the patient, sort of everybody forgets it, the patient leaves, and then later in the day you remember you forgot to make plans for the colonoscopy, and then you have to stop what you're doing and fix it in the medical record, make the orders. You also have to call the patient, give them the information about it. You forgot, and it's a little bit embarrassing, right? Lose a little bit of trust. That is a huge source of wasted time. It's like some kind of anti-work that we bring upon ourselves, and every clinician does that. Nurses, doctors, everybody, and we need to reduce that. And that's why we can set up multi-agent frameworks to help us avoid these things by connecting to the guidelines that we choose, or to whatever resources we choose, or to instructions we choose, to simulate this colleague who is watching the consultation and saying, "Please remember, you wanted to do this."
It's not always there.
It's not always there. Sometimes it is, and when you work with, for example, nurses who can do that, it's a privileged situation. I've been so fortunate sometimes, but it's absolutely not the rule. Sometimes you're just alone. Try not to forget things.
And I think what we're trying to design for is to cover lots of different interaction types. And this is one sort of interaction type that is different from the sorts of agents that we're used to. We're used to reactive agents where a user writes a prompt and then expects some sort of response back. But actually what Les is referring to is something that is a second pair of eyes in that consultation room, helping the doctor. And you could imagine, for example, an agent that is analyzing the transcript, the conversation in real time, and then prompting the clinician in real time. So they're asking the right questions at the right time. For example, pulling up guidelines. Do we need to, what do we need to book as a follow-up for this current situation, this current patient, given the context from the EHR, given the context from local guidelines? Another example that we're working with some partners on is identifying mentions of medication during conversation, comparing against drug databases and seeing, are there any contraindications, are there any side effects of this medication that are potentially relevant to this patient? If the patient maybe has mentioned some other previous side effect, prompting the clinician during the consultation so they can ask appropriate follow-up questions, so they can make the right decisions when it matters, as opposed to, remembering sort of like 3 hours later, I should have asked that question, or worse yet, never remembering at all because you've moved on to something entirely different.
Or the patient calling you up and said, "Shouldn't we? Wasn't there something about a colonoscopy?" That's not nice.
And so from a software perspective, we're designing a framework that allows product builders to integrate really advanced AI capabilities into their software that makes sense for each individual industry, each individual product type. We don't think that just a sort of a chatbot is the only way to do it. We think it makes sense for certain use cases, but exactly the situation Les describes, it needs something smarter. And that's sort of the rationale behind the framework that we're building. Allow the experts in individual specialties, individual end user workflows to build those really, really strong AI-powered agentic flows for their end users.
One way to take off cognitive load is some of these tasks that we do at the end of a consultation, or it could be like ordering imaging. Let's take ordering an MRI. For an MRI, to order that, a long checklist of, you have various metallic implants. You have to say no, and yes, and then write the type of implant, stuff like that. Height and weight, and does the patient have claustrophobia or allergies and kidney function and stuff like that. It takes a little bit of time to click, and it also takes a little bit of time to actually get the information. That is exactly the kind of work it would be wonderful to offload to an agentic system, so that your job becomes to look at it and verify it. instead of actually doing the work. And that takes off a little bit of this work that leaves you with less of a break from this doctor doing planning to the person making it happen, right? So that's the switch that's a little bit painful sometimes, and it makes it softer and less.
So for a developer to use our agentic framework, you can configure an army of agents. An agent is comprised of the orchestrator. It's the core large language model that is taking in the prompt or the natural language query and context. And then it's got capabilities that it's attached to, what we call experts. And these experts are themselves agentic. It could be an expert that is dedicated to fetching patient information, being the expert on patient records. It could be an expert that is dedicated to pulling reference material from third-party knowledge bases or regional guidelines. Some of those experts we mentioned, for example, medical calculator. And so as a developer, you can add each of these experts onto your agent and customize it to exactly your needs and your end customers' needs. You can also build your own experts, so they have deep integrations into your own systems that you're building to ensure that you're getting the most integrated agent that understands your end user's workflow. And then the traditional sort of agent integration you might expect is a sort of chatbot, allowing a clinician, for example, a nurse, a doctor, to write or speak natural language queries, do this, ask questions about patient records, for example, and the orchestrator will interpret that query and will invoke the right experts to carry out that task, and then eventually come back to the user with the result. That's the traditional workflow, but we're also working with customers that are doing much more complex workflows, those that are focused on full end-to-end automations. So where it's not a clinician requesting a particular thing, but it's taking in, for example, patient intake forms, and it's processing those in a understanding what's required, ensuring that they're passed on to the right people, summarizing them and so on, carrying out multiple AI-powered tasks before it then goes on to the next step, helping with that administrative burden. We're also working with customers on entirely patient-facing interactions as well, bring agentic workflows to patients. And then I think possibly the more interesting one is then, they're all interesting. One other interesting component is then actually using agents in live consultations, where they are analyzing the conversation in real time and identifying things, helping the clinician to ask appropriate next questions. For example, if a patient mentions a certain medication, pulling up all the information about that medication, finding contraindications, finding side effects to that, and analyzing the rest of the conversation to see, is there anything that the doctor should be aware of? If the patient's already mentioned a side effect or a symptom that coincides with one of the side effects of a medication they're taking, the clinician should probably be made aware of that. Are there regional guidelines that the clinician should be aware of for prescribing something that they should know before it's too late, before the patient's walked out the room? There are other sort of more advanced use cases for agents that go beyond that sort of traditional chatbot that I think we're used to with the likes of ChatGPT.
Henrik, for my sake and for some of the audience, can you just describe or define some of these terms that we hear with like agents and orchestrator and experts and so forth, just so we understand what they are?
So as we talked about, an agent is a large language model that can be connected to certain capabilities to either pull information from the world or take action in the real world. And within our agentic framework, we've split it into two key components. The first is the orchestrator. The orchestrator is the initial agent that takes in that initial query, maybe a whole lot of additional context, and it figures out what capabilities it needs to use to then carry out that task. Those capabilities are what we call experts. Experts are dedicated sub-agents. They are themselves often large language models that are connected to a range of their own capabilities, but they're dedicated to a specific domain. So that could be an expert that is dedicated to pulling certain information from patient records. It could be an expert that is dedicated to full knowledge of a particular like reference lookup database. We have integrations with Amboss, for example, as a good example. They know how to search those content databases and how to then answer queries about diagnoses, symptoms, and so on using trusted databases. That knowledge from the expert comes back to the orchestrator, and then the orchestrator then figures out, does it need to use additional tools and capabilities before it eventually goes back to the end user. Within a patient record, there's an immense amount of information. And a lot of it is not at all relevant for each individual encounter. It is relevant in the grand scheme of things of that patient's history, but finding the needles of important information within that haystack of megabytes of data is really, really tricky. And when we think of data from a developer side or a technical side, we're used to these beautifully structured APIs that have structured, easily searchable data. The truth is that in many systems, patient records are unstructured. Some systems are still moving from pre-digitization, so it is large reams of unstructured text where there is important nuggets of information, but to filter through and find that is incredibly tricky. And so whilst there are a lot of agentic frameworks that have memory built in, and they work very well for their particular use case, we've designed ours around the problems and challenges of healthcare. And the mix of semi-structured and entirely unstructured data to help clinicians be able to find those nuggets and to help our large language models to correctly answer questions based on that context. And so that is effectively what memory is ensuring that we can sift through the reams of information to answer questions accurately and with that traceability to the original bit of information that we sourced it from.
And I think that some of the genius about the solution is that everything is also wrapped within a governance layer around the solution. So Henrik has been explaining the orchestrator and all of these experts and the memory component. We're starting to talk about a really, really complex system all in all. And for that complex system to be reliable, we're taking a lot on our a lot of responsibility on our shoulders in terms of making sure that we're making the best possible governance layer around these large language models. Because everyone that has played a lot around with large language models or tried to put them into production, they know that they can be difficult to work with, and they know that they can have this nice demo system in place. But as soon as they're going into these production settings, then they see all of these anomalies in the data sets and that they're crunching, and then they find that these LLMs can have these spurious correlations or different behavior that is definitely not suited for a clinical setting.
So from a developer point of view, this is what I've heard you talk about, Henrik, where we found a bit of a sweet spot, if you will, between completely build your own, start from scratch, or something that is pretending to be appropriate to your particular context off the shelf. This is something a little bit in between those two.
Yeah, absolutely. I think the fully off-the-shelf solutions just do not meet the needs and complexities of real clinical work. And particularly if you're a software company that wants to build a really good experience for your end users and wants to make sure it's integrated, it isn't a real option. So they are looking at building their own, and the complexities don't seem very high initially. Building agents is quite simple with open source frameworks, but it's when you suddenly get into something that works 9 times out of 10 is great for a demo. It is terrifying when you get into production, and particularly in healthcare. And so those checks and balances that we built in there, as Lars mentioned about the guidelines and guardrails, that's really, really important. But it's also about building the powerful features to know that we can actually pull information from large contexts, from third-party references, and do so in a traceable way.
Yep. We're basically just making it a lot simpler also to set up a production system around a multi-agent framework. We have an example from last week where a developer got a multi-agent system calling 5 different experts up and running in a matter of like 2 hours time for them to at least demo it. And then they were reconfiguring the system and are still, but they can now test it in front of the clinicians, get feedback, and thereby get the final fine-tunings in place to actually put it fully into production. And that's magical, right? Because that gives all of these developers a lot of opportunities for building features faster into their applications and testing them faster with their end users at a production level.
So with what the guys have just said, in terms of the specifics of how these frameworks are put together, the safety systems and so forth that are built in, the fact that there's memory in there as opposed to just pretending to memorize pieces.
Yeah.
From a clinician's perspective or like your experience, can you tell us what it's like without these tools?
Yeah. Yeah. For example, ordering things, let's say, imaging, right? You with a patient and you want to order, like, let's say, an MRI, and you need to go through a long checklist to see if to document does the patient have this metallic implant or this implant, and yes, no, and you're at what type, and you need to write allergies and kidney function, and does the patient have claustrophobia, and who signed this, and there are these forms, and I'm sure they differ from place to place, but they're all comprehensive, and it takes a lot of time. And when you go from making the plan, this is just one plan item out of many others, right? You go from making the plan to actually filling out these things. You make a mental switch from being the doctor planning it to being a person making this program actually do it. And it's the more of that you have, the less time you spend on making sure this is the right plan and that you remember everything. And with an agentic framework, you can outsource this. You can have an agent draw this information from either the conversation you just had or from the EHR and fill it out for you to verify. And that's where you need this traceability with AuditAbout. If it says the kidney function is this and that, it's not okay if it's right 9 out of 10 times, right? This is good for a demo, but it needs to be right every time. And you also need to be able to verify it. Click on it, hover on it, whatever people find out. It needs to be easily verifiable, these things. So the job is done for you. It's all there, and you can check it if you don't if you feel you need it. And this is just one example. Imagine the next thing is making a prescription for a drug, like, I don't know, 20, 30 clicks normally. And for each click, there's a risk that you do it wrong. And you might have several drugs. And imagine this multiplied over all of the doctors and nurses and other healthcare professionals doing this daily. The amount of errors, some severe, but many not severe, is staggering. The potential for errors here is staggering. And for each of these, if we just look at the non-severe errors, they're just irritating or stupid, it takes a lot of time to correct it. You have to remember it. Even worse, the patient has to say this is wrong. It's embarrassing and it erodes trust. And we have to fix it. It's this negative work we need to avoid.
So, surrounding our agentic framework, we have developed guardrails. And guardrails is this governance package that you get for free when using our agents. And that is our engineers, our machine learning engineers, our product engineers that have been thinking long and hard on making sure that we're producing output from our agents that is reliable, trustworthy, traceable, and so forth. That also means that we, from a compliance standard, we have taken care of all of the regulatory compliance. So you don't have to wrestle with that when setting up an agentic system. And I can tell you that that's a lot of work in itself. So a lot of times we're talking about traceability in AI. We're talking about explainability in AI. And sometimes we have a difficult time on understanding what it actually means. To give you an example here, when I use ChatGPT in its reasoning mode, then you see that it's giving you explanations of what it's doing. And if you give it some complex tasks, then look long and hard into those explanations, and then you find out what it's doing is definitely not linear, and it's definitely not sequential. We want to open up that engine room for the developers that are using our solution so that they can trace the chronology of the reasoning. because that will explain you a lot about how you design your system. And we want to make sure that the reasoning path of this agentic system that our developers are producing based on our platform is as sequential and reasonable as possible, because that's where you have the most optimized system possible.
This movement is has a lot of momentum. If I think about sort of A2As and MCPs and things like LangChain and other companies like that, this has really got a lot of momentum behind it. This is a big industry. And you've been working on this for at least a year, maybe a couple of years now, building specific solutions as you've described here. Can you just help us differentiate what it is that you're working on from the rest of this beast?
So ultimately, they are all tools to help developers build agentic flows. Where I think we're differentiating is obviously we're focusing a lot on the requirements of our customers within the healthcare space and the broader health and medicine space. That includes, as Lars mentioned, the governance layer and guardrails that we've included that ensure that we meet all the compliance and regulatory needs for our customers. So that as the developer, you don't need to worry, is this HIPAA compliant, or at what point does this become a medical device? We're working to ensure that that complexity is solved for you, and you can just focus on product building. Additionally, there's a lot of technical decisions that you need to make, even when you sit on top of something like LangChain, LangGraph, and similar, or if you build it yourself. What databases do you want to use? What protocols do you want to use? And the market is moving incredibly quickly. That as a software company where you're primarily building a practice management system or electronic health record system, it's a gamble right now to pick a particular tech stack. We're effectively saying we can take that risk. We're going to make the right decisions. And if it turns out that, the market moves on, we want to ensure that we're investing in standards. We, for example, have picked open standards as much as possible, not just because it means that it's really easy to build on. There's a lot of open source communities and libraries and packages that already exist, so it makes it a lot easier for you to build on top of Corti. We made, for example, the decision to use A2A as a way to interface with our system. A2A is originally a protocol designed by Google, is now fully open source, and there are dozens of already open source integrations for this system. The reason I like that is that there's also not a lock-in into our system. In essence, if you realize that you graduate from our system, you can actually replace us at any time. I think personally, as a product person, that gives us a lot of good motivation to keep on ensuring that we're building a much better product than you'd ever be able to do internally, right? Because if you can be replaced at any time, we need to always be on our toes. So I quite like that personally, but also from a perspective of companies building really powerful agentic flows. There might be certain aspects that we've not built in our system. We've instead designed the agentic framework to be really, really configurable. So if there's something you don't like in it, if you want to customize how the governance layer works or the guardrails work, we've designed for that to be disableable or replaceable or configurable from a developer perspective. That means that you can get to market really, really quickly with something that is more or less unconfigured. And as you see more requirements coming in from your customers, you can extend your integration of Corti's agentic framework with more complex configuration, more advanced components. On top of that, we've also built an ecosystem of healthcare-specific integrations. That is, for example, integrations into reference databases, into PubMed, for example, but also medical calculators and scheduling systems and patient record systems. And that's available on our expert store. So you can very easily add those to your agents and give your agents instantly new capabilities without having to lift a finger. And then the final concept, or the final component that I think is really important is, as we mentioned before about memory, healthcare is extraordinarily complex. There's huge amounts of data involved in patient records, reference databases, and so on. And so we've built memory and other sort of capabilities within our system, handling of files, for example, that are suitable for healthcare and the specific needs and challenges of healthcare.
We want AI to start producing more value in healthcare, and we want that immediately. We see the first introduction of AI solutions as the generation one. And generation one, according to us at least, is these ambient scribe solutions. They're taking out a vital part of the workflow and helping the clinician not having to write the full documentation on their own or dictate it. And they're super powerful in listening to the dialogue and thereby getting the dialogue with the patient into a format that is needed downstream. For instance, SOAP formats and so on, or referral letters and so on. However, this generation one AI is, in our opinion, not enough because there are a lot of tasks that are downstream. So these derivative tasks from, for instance, a patient encounter, like order medication, order lab results, order scans, and all of that, there needs to be taken some actions from the AI system in order for the AI system to really help the clinician in need of help and in need to alleviate their cognitive burden. So generation two are the things that we're the most excited for here in 2026, being introduced at scale. And we have a lot of customers out there that are right now introducing them into their production setting and getting really, really good results on that. What I personally am super excited about are what we emphasize as generation three. And that's the systems that can be running for a longer time. These agentic systems that can take more workload on them, where they can take more actions in chronology and in sequence. That's where the agentic systems are getting really, really magical because then they can start offloading real work from real human beings such that these human beings can function and focus on the task at hand that they're specialized within. So to take an example, that is, there are a lot of coding work out there. So medical coding, where they need to assign ICD-10 codes, for instance, to medical notes, etc. And you want agents to work long haul tasks in terms of coding these cases correctly, and also audit the coded cases against different systems and send them out of the healthcare system without any human intervention. So we see the introduction of AI in healthcare in three phases. We call them generation 1, 2, and 3. We see generation 1 as these ambient scribes that are taking over a burdensome workload. That is the documentation workload. So that's when the clinician is having a conversation with the patient, for instance, and where the AI is understanding what is being said and then transcribing and formatting that into medical documentation. We see generation 2 as these agentic systems that are starting to take action, real action that is really offloading the clinician in their everyday work. For instance, ordering medication, ordering lab results, ordering imaging, or scheduling the next time, having these follow-up conversations with the patient and so on, as a first derivative of the encounter with the clinician. Then generation 3 are the longer running tasks, where an agentic system can be set loose in terms of actually completing a longer running task with multiple different actions in sequence. That's where the real magic will start happening in healthcare, and that's where you can really start talking about having a colossal impact on the workload and also the clinical impact to the patient. If you're a developer that wants to build something AI-based within healthcare, then Cordy is the right place for you. You go into Cordy.ai, you can get an overview of all of the agentic capabilities on our expert store, where you can see the configurations, you can see the explanation of those experts, and then you can click on one of them, you can log in, and there you get into our console, you can try it out and test it out yourself, you can prompt these experts and this configuration of agent. And if you feel like this is something for you, then you basically just get started by an API token, and you can get your code up and running in minutes. We even have like a quick start for LLM-based coding, such that you don't even have to code yourself. You can get an LLM to code for you and get that into an application.
So what is it that, if you're a developer out there, as you say, Lars, what do you need to bring yourself in order to actually build something that's going to be useful and applicable and scalable in a particular context?
Yes, and normally the developers that are coming to us, they have a good understanding of what they're trying to solve. And some of them are also using our content online. We have these solution pages where we're showing different examples of applications, and some of them are getting into conversations with our activation team where they are presenting what they're intending to build, and our activation team gives them some pointers towards what we have seen before, what we've seen working, and so on. So developers are normally, by using us as a sounding board, also equipped with a lot of empirical evidence on what builds a really strong agentic system inside healthcare.
I love it. So you want to bring a really good understanding of what problem you want to solve.
Yes,
Nice.
and if you don't feel like you have that crisp understanding, then we can also help you on getting to the end goal.
Nice.